Hello everyone, I'm Paul and today we're solving problem 2419, longest subarray with maximum bitwise AND. This is medium and the key for this one is observation, so let's start. We are given an integer array nums of size n, so let's say we're given this. This is nums and this is our job. First we need to find the maximum possible bitwise AND in the array. And then we need to find the length of the largest subarray with this maximum bitwise AND. Now, in case you know what bitwise AND is, let's say we have 5 and 1. And this in binary is 1, 0, 1, and 1 in binary is 0, 0, 1. And now we are doing 5 and 1. And here, when we are using this operator, this only returns 1 when both bits are 1. So we are iterating this from right to left, and we start in this position. And here, both bits are 1, meaning the resulting value in this first case is 1. Now, if at least one of the bits is 0, the resulting value is 0. So for example, next we are here. And we have 2 zeros, so the resulting value is 0. Finally, we are here and we have 1 and 0. Given that we don't have 2 ones, the resulting value is also 0. So 5 bitwise and 1 is this in binary, which is 1 in base 10. Now here we have the key observation for this problem. Whenever we are using the bitwise AND operator and we have one number that's larger than the other, the resulting value will always be smaller than the larger number. For example, if we do 5 and 2, the result is 0, and this is smaller than 5, which is the maximum number here. If we take 3 and we do 5 and 3, the resulting value is 1, 0, 0. This is 1 in base 10, and 1 is smaller than 5. If we take 4, this in binary is 1, 0, 0. And if we do 5 and 4, the result is 0, 0, 1. And this in binary is 4 in base 10, which is still smaller than the larger number here. So first we need to get the maximum possible bitwise AND in this array. And the conclusion from a few seconds ago is that the maximum value that we can get is given by the maximum element in the array. In this case, the maximum element is 3. So now we need to return the length of the longest subarray with bitwise AND equal to 3. And remember, 3 is the maximum. And we know that if we compare 3 against anything smaller than 3, the resulting value for bitwise AND will be smaller than 3. So the only way to form a subarray with this bitwise AND is if every element in the subarray is 3 in this case. And what this means is this is the only valid subarray. And this has a length of 2, so we return 2 in this case. Now, in case you know what a subarray is, it's a contiguous sequence of elements within an array. So if we take these elements, we have a subarray. This is also subarray, this is also subarray, and this entire thing is also subarray. Now we can't form a subarray with 1, 2, and 2 because these elements are not contiguous. So the approach is simple. First we find the maximum value here. We will call this mx, and this is 3. And next we are iterating this from left to right, and we are checking how many consecutive 3s do we have as a maximum. So we will have a variable current where we are storing current 3s we've seen so far. This is initially 0, and result is initially 0. So first we are here, this is not 3, so we continue. Now we have a 2, this is not the maximum value, so we continue. Here we have a 3, so now the current value is 1, and the result is the maximum among current and the result, so this is now 1 also. Now we have another 3, so we add 1 to current, and the result is the maximum among this and this, meaning 2. Now we are here and this is not free. And whenever we find a value that's not free, we can reset current back to 0. And we keep 2 in the result because this is greater than 0. Finally, we have a 2. This is not the maximum, so we continue. We reach the end and we return the result, which is 2. So this is basically the entire approach. Time complexity will be big O of n because we are iterating this, and space complexity will be big O of 1. So now let's go with the code and hopefully you will get the idea. First we say n is length of nums, and we'll say mx is the maximum value in nums. So this is the maximum bitwise and in the entire array. And we say current is 0, result is 0, and now for every index in range n, if nums I equals the maximum value, we add 1 to current plus equal 1, else we reset current back to 0. And each time we want to update the result, so this is equal to the maximum among result and current, and finally we can return the result. So this is it for the code. Now I will submit this and see if it works. As you can see, this works and it's efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.